Hello guys and welcome to another video tutorial series on searching algorithms. And today we're gonna discuss on one more important question on searching algorithms which is most commonly asked in any product-based companies such as Oracle, Microsoft, etc. And the today's problem is you need to find the first occurrence of a given number in a sorted array. And you need to write an algorithm which will find out the number in the given sorted array within log of n times. So let's jump into the solution of this problem and see how we can solve this problem and write a most optimized code so that we can solve this problem in log of n times. So before jumping into the solution of this program, let's first understand the question. So the problem statement says that you need to find out the first occurrence of a number within this sorted array in log of n times. So here you can see that the array that is provided over here is in a sorted order. So here you can see we have 2, then 5, then 6, 8 and then 9. And our goal is we need to find the first occurrence of this given number. So if we take the example, the first time the number 5 is occurring within this sorted list is over here, that is the index position 1. So we can easily solve this problem using plain linear search. But if you consider a linear search algorithm, you know that the complexity of a linear search algorithm is order of n. But here if you see that the problem statement says that you need to find out the solution in log of n times. So here to solve this problem we cannot use a plain linear search algorithm to find out the solution. So let's find out how we can solve this problem in log of n times. So let's understand the solution using our whiteboard session. So here you can understand that the program demands the solution within log of n. So it is very clear that if we need our solution in log of n times, then we have to follow the algorithm of binary search. But the normal binary search will not give the correct result over here because the binary search will return the occurrence of the number, but it will not ensure the first occurrence of a given number. So we have to modify the existing binary search so that we can get our desired result. So let's see how we will do it. So here we will be solving this program by modifying the existing binary search. So as you know, in binary search we uses 3 pointer, one as the left pointer or the low pointer, one as the right pointer or the high pointer, and one as the mid pointer that denotes the middle element over here. So with this principle of 3 pointers, we will solve this problem in log of n time. So let's see how we will do it. So the approach of solving this problem is quite easy. We will be solving this using plain iteration process. So what we will do is we will be modifying this simple binary search and we will try to get our desired solution. So if you know that in our plain binary search, we write a while loop to iterate the entire array. So here, first we will write the while loop. So until this low doesn't cross the high index over here, we will be keep on iterating this entire sorted array. And in normal binary search, we see the mid element over here. And if the mid element matches with the target, we normally returns the index of the element. So this is the plain condition for a binary search, that we search the middle element of the array and if it matches, we return the mid element that we got the number. But here we need to find the first occurrence of the number. So for example, our mid is pointing over here, and if we see this condition using our normal binary search, here we can see that our condition satisfied, that a of mid is equal to target. But this is not the first occurrence of the element, because we have some duplicate element also at the beginning of it. So we need to enhance this condition a bit more. So rather than only checking the middle element over here, we will enhance this condition over here. So what we'll do, we will also check that whether the element before that matches with the target or not. So here before returning the result, Here let's consider we have the middle element over here. We will be checking that whether the element before this mid element is also same or not. So if the element before the mid element is not equal to target, so here we are using the not operation, then we will be returning the index of the element. So to understand this condition more clearly, let's take a valid test scenario. So let's take that we need to find the first occurrence of the element 6 over here within this sorted array. So here for the first time we have the low pointing to the 0th element, high pointing to the last element of the array, and mid pointing to the center of the array. Now if you try to iterate on this condition, we will see that the A of mid is equal to target, which is the basic condition for a binary search. So here the condition satisfied. Our mid element is equal to our target element, that is 6. But here if you see, this is not the first occurrence of the number. So we also need to check that whether the element prior to that is also the same element or not. So here we are checking another condition, that if the element before that, that is mid minus 1, which is this one, if this element is not equal to target, then we are concluding that this is the first occurrence of the element. But here in this case, the entire condition fails. So what we'll do, we will write the next condition over here. So if the mid element is equal to target, and the element prior to this one is also same as the mid element, then we will set the high pointer over here. So what we are doing over here is like we are checking the mid element over here, and we are checking that whether the element prior to that mid element is same or not. So if it is the same element, means this is not the first occurrence of the number. Means we need to iterate on this sub array to find the first occurrence of the number. So here what we are doing is like we are setting the high pointer from here to this element, that is high minus 1. So now over here our low is still pointing to the first element of the list and high is pointing over here. Now we are again calculating the mid element from this array. Now we are again checking that whether the mid element is equal to our target element or not. So here you can see that the mid element is not matching the target element. So both of this condition fails. Now we will write the third condition of our binary search, and that is if the mid element of the subarray is less than the target element, which means we have the desired target element on this side of our array. So here, just like normal binary search, we will set the low pointer to mid plus 1. Else, we will set the high pointer to mid minus 1. And here we will close our while loop. So if you just go through this code carefully, you can see that all the condition we have written over here is same as our plain binary search. For example, this two condition is same like our basic binary search. Here also this condition of finding the middle element is also same as the plain binary search. Only thing is like we are just enhancing one more condition over here, and we are making an enhancement to our existing binary search to get our desired output. So I hope the algorithm and the way we are planning to solve this program is quite simple and easy to understand. So before writing the Java program to implement this solution, let's first understand this solution visually using our visual display board. So let's first understand the algorithm, that how we will be calculating the first occurrence of a number in a sorted array. So at the very beginning of the program, we will be assigning 3 pointers. The low pointing to the first element of the list, the high pointing to the end of the list, and the mid pointing to the middle of the list. Now we have to iterate over this list, checking the condition that whether the low is less than equal to high or not. So if the low is less than equal to high, we will check the value of the mid element. And depending on the value of the mid element, we will keep moving forward. So here in this case, for the first time, the value of the mid is 6 and our targeted element is 5. So the value of the mid is greater than that of the targeted element. So it is very clear that our targeted element is lying on the left side of the mid. So here what we will do, we will set the high pointer to mid minus 1. So on the next step, we will again calculate the mid element. and we will see the value of the mid element. So here the value of the mid element is 5 and the value of the element before mid is also 5, which means the element 5 is not the first occurrence in this sorted array. So we will keep on iterating forward and we will set the high pointer to mid minus 1. Now on the next step we will again calculate the position of the mid, and here also the value of mid is 5. Now we will check that whether the value of the low and the mid is equal or not, which means we have reached to the starting point of our array and we do not have any element before this. So we need to break the condition over here and we have to break the while loop. And here at the end of this iteration we get the first occurrence of the number in the sorted array. So here at index 0 our element 5 is occurring for the first time in the sorted array. So now let's see how we will implement this algorithm using our Java code. I think you have already understand the way we will be solving this problem. So let's write the Java program to solve this problem. So before writing the solution of this problem, I would request you that if you like the solution of this problem, don't forget to like and share this video. And if you are new to this channel, don't forget to like and subscribe to my channel and hit the bell icon so that you do not miss an update from my side and you are always prepared for your next interview. So let's again go back to the solution of this program. So let's name the function find first occurrence. And here we will be passing two parameters. One is the sorted array and next the targeted element that we need to find. So as you have already seen that to find the solution of this problem using a modified binary search, we need to create three variables. One low that will be pointing to the first element of the list, one as high that will point to the last element of our list, and one as mid which will point the middle element of the list. So here first we will define the three variables. So the next step is like we need to iterate over this array. So we will write the while loop. So here you can see that till the low pointer doesn't meet with the high pointer, we will keep on iterating over the array. Now here we will write the first condition of our solution. If the mid element matches with the targeted element and the element before the mid element is not equal to the target element. So if this condition is valid, means we got the first occurrence of the element. Then we will return the index of the element. Now we have to find the next condition, that is if the element before the mid element is also same as the target element. So this statement means that both the middle element and the element before the mid element is equal to our target element. So this is definitely not the first occurrence of the number. So here we will set the high pointer, which means that the element should be present on the left side of our targeted array. So now once this two condition is done, means we have already implemented the enhanced binary search. Now we just need to write the normal basic condition for the binary search. If the target element is greater than the mid element, means we have this targeted element on the right side of the array. So we will set the low pointer to mid plus 1. Else we have the targeted element on the left side, means we have to set the high pointer to mid minus 1, and at the end we will close the while loop and we will close the function. So one more thing that you need to calculate is the middle element, which I forgot it over here. So here you have to find out the mid element. So every time we are entering the while loop, first is like we will find the middle element and then we will check all this condition. So I hope the solution of this problem is quite simple and easy to understand. So if you do not understand the solution, please let me know in the comment section below. And also I will be providing the entire code snippet in the description below. And one more thing is like, if you want to optimize this code even further, you can merge these two conditions together into one. So I will provide that code in the description below. So feel free to look into that code and try to understand from the solution. So hopefully the solution of this problem is clear to you. And since we are using a modified binary search over here, so the complexity of the problem is log of n, which meets our desired problem statement. So let's move to the next question of our searching algorithm. And before moving to the next video, I would request you that if you like this solution, don't forget to like and share this video. And if you are new to this channel, don't forget to subscribe and hit the bell icon so that you do not miss any update from my side and you are always ready for your next interview. So see you on my next video. Thank you.